All right, in part C, we're asked to graph r equal 4 minus 4 cosine theta. So once again, I'm going to look at what's going on here on the r theta axes. Now theta is just theta, right? So the angular frequency is 1. That means I've got the same quarter marks I've always had. So one cycle is going to be graphed over 0 to 2 pi. And I got to plug in these things and see what's going to happen. So when I plug in 0, I get 4 minus 4, which is 0. You plug in the pi over 2, you get 4 minus 4 times 0, so that gives you 4. At pi, you get 4 minus 4 times negative 1, so that gives you 8. At 3 pi over 2, you're back to 4, and at 2 pi, you're back to 0. So you connect this up, and this is supposed to be a nice cosine curve. So what's going on then over here in the xy plane? Well, the good news is there's no negative r values. That's usually the stuff that gives students trouble. And so what's happening is as theta goes from 0 to pi over 2, the r goes from 0 to 4. So that means I start at 0, which is the pole or the origin, and by the time I get to theta equals pi over 2, I'm 4 units away. From pi over 2 to pi, the r is still increasing from 4 out to 8. So between pi over 2 and pi, it's still getting farther away. So it's still increasing. Oops. To 8. And then from pi to 3 pi over 2, now the r starts to decrease, so it's going to pull itself in. Like that. And from 3 pi over 2 to 2 pi, it goes from 4 and tucks it into 0. Alright, so this is one of those things called a cardioid because it looks like a heart. If you turn your head sideways, it looks like a heart. Okay, so that'll do it then for C. Alright, part D, similar to part C, except instead of a 4 there we've got a 2, so we'll see what kind of mischief that brings. So if I graph this on the r theta axes to get an idea what's going on here, I've got the same quarter marks because the angular frequency is 1. I plug in 0, cosine of 0 is 1, so that gives me a negative 2. I plug in pi over 2, I'm up at 2. At pi, I'm up at 6. At 3 pi over 2, I'm back to 2. And at 2 pi, I'm back to negative 2. So that means I'm crossing through the r theta axis, or the theta axis rather, at some point. And since those are points where I cross through the pole and correspond to tangents at the pole, I need to find out what those are. So I need to find the zeros of this function. So what I do is I set this function equal to 0. This gives me cosine theta is minus 1/2. And so I know that's at 2 pi over 3 and 4 pi over 3. So when I go to graph this guy, pi 2 pi over 3. Oh, I'm sorry. This is completely wrong. This gives me cosine theta is positive 1/2, which means that theta is pi over 3 and 5 pi over 3. So let me make that adjustment. I should have known it crosses between 0 and pi over 2 and 3 pi over 2 and 2 pi. So, all right, that's fixed. So I have to dot in these lines then. So we're going to pretend that's the dotted line. Theta equals pi over 3. And then I'm going to dot in 5 pi over 3. Like so. Okay, now, it starts off negative. We don't like negative R values, but that starts out negative. It goes -2 to 0 as theta runs from 0 to pi over 3. So once again, the negative means that instead of thinking of this graph starting here and doing that, it's going to start here and do this. Okay, so you always reflect it through the origin there. That's where you're going to start. So we start off 2 units, but to the negative side. And as theta runs between these angles, the R goes from -2 to 0, which means it's going to come in and tuck itself into the pole. Now, from pi over 3 to pi over 2, the R turns positive, and it goes from 0 up to 2. So now, between these two values of theta, as I rotate here, R is positive, and so it comes up to there. Between pi over 2 and pi, the R keeps increasing. It goes from 2 up to 6. So it comes through like that. And then from pi to 3 pi over 2, the R goes from 6 down to 2. So it's going to come in like this. And then from 3 pi over 2 to 5 pi over 3, the R goes from 2 to 0. So it's going to tuck itself in. And once again, it's supposed to head in along the tangent at the pole. And then from 5 pi over 3 to 2 pi, instead of graphing in here, we're going to be graphing in here because the R's are negative. We pass through the pole and get that. Okay? And with the way today's going, this is about as good a picture as I'm going to be able to give you. This is one of these limosons that have an inner loop to it. And if you go on to calculus, we want to find the area of that inner loop. It's going to be important for us to know where that inner loop was traced out. So the inner loop was traced out here for the negative R values. Okay, so that'll do it for number 1.